Hi, my name is Angelica Gama. I'm from Bogota, Colombia. This is assignment number 5 for Introduction to Music Production at Coursera.org. Today I'll be trying to explain the most important differences and the most important features of a convolution reverb and an algorithmic reverb. So, first of all, what is a reverb? It's an effect that gives us the sense of a space, and it's built with many delay blocks. The sound waves reflect on various surfaces, and that creates some reflections that can happen at different times depending on how long it takes for the sound to reach its surface and back. Here you have the picture of how the reverb acts. You have a first impulse, and then you have early reflections, and after that you have later dense reflections. Okay. Reverbs always have some parameters, like the pre-delay that determines the amount of time between the original dry signal and the onset of early reflections. The room shape and size. This control adjusts the size and shape of the virtual room. It can change the pattern and spacing of the reflections. Sometimes you have the density that controls the density of reflections in the reverb tail. Sometimes you have the diffusion that controls the rate at which the reverb tail reflections will grow in density. And sometimes you have the reverb time that is called also the decay time. This controls the length of the reverb tail. Okay, let's start with two different types of reverb. We have the convolution reverb. Like in this case, I have a picture of the Altiverb 6. This type of reverb consists in a recorded sample of an acoustic space based on a mathematical convolution operation. Convolution reverbs basically record and process the reverberant and particular behavior to a real acoustic space. This type of reverb is going to recreate the reverb of a real existing place. In this case, for example, Notre Dame Cathedral, where you have different options. I'm going to show you here in a Studio One version 2.6 how this kind of reverb will work. So here you have an Altiverb, I have a mandolin, and you're going to listen what is happening. For example, I select this one, the Church of Notre Dame. You have this place. Here you have information about the place, and you have different placements of different microphones. Or this one in the same place. Maybe you can change. You say, no, I want a church. Like this one. And it gives you more information about the placement, about the place that you selected. For example, this one, I can select the Sydney Opera House. Maybe this one. Or maybe this one. And you see, these are real places. Okay, now we're going to continue with this information. Here you have something about an algorithmic reverb. You have different parameters. Digital reverbs use algorithms to represent the natural effect of reverberation. In this type of reverbs, you can find parameters such as decay, pre-delay, early reflections, among some others. Algorithmic reverbs use multiple feedback delay circuits which create a diminishing series of sounds. The early reflections are controlled by variables such as room size, room shape, and stereo controls. The differences between the algorithmic reverb and the convolution reverb. Algorithmic reverb can be very versatile. You should use it if you want to emulate a traditional reverb with extra whistles. You can adjust a wide number of parameters. This type of reverb recreates the reverberation effect of a place that does not exist through different algorithms. It consumes less CPU power. And the convolution reverb, as you saw later, before, convolution reverbs can produce a very realistic snapshot of a particular acoustic space, for example, the St. Paul Cathedral or the Sydney Opera House or other places. They have more limited options to modify the various parameters that an algorithm reverb can offer you, and the sound is more real, but you will have to use more CPU power. You're going to listen now a different type of reverb, and we're going to see an algorithmic reverb like this one. You have different parameters, and if you change the pre-delay, it's gonna change here some effect. So now let's listen to this one. You can also change the place that you are emulating. And of course the amount of the sound.